Right, it came up in conversation the other day how the correct way to see the sun and the planets is to remember that the sun is moving all the time. Otherwise we see just a radius, excuse the bus, we just see the radius and the circumference. Now remember that Kepler told us that the radius is a square of a number and the circumference is the cube of that same number. Sorry, the duration period of the orbit around the sun. So the period of orbit is the cube of a particular number, which, where the fuck are we? Oh yeah, alright, so we go to this website here, which is known as solar geometry, and we see these various things. I'll leave a link for this down below, but it can be done better. You can see this in a different way if we work out some of the math involved, which we'll see here. Now, what we have is the planet, then we have the radius, and then we have the orbit. And how do you relate a distance to a period of time? This is the square of a number, and this is the cube of the same number. So how do we find that number, which is both a distance and a time? Well, the first thing we do is we find out what the cube root of that period of time is. 88 days, 225 days. And we take this figure here, the cube root of the orbital period, and we multiply it by 19.81 kilometers per second. And we arrive at a number which is slightly better than the official figure of 20 kilometers per second. And what that does is that we multiply this time by the speed, and we come up with this number. And when we square that number, we come up with a number which is almost identical to the radius in every instant. Never more than 1/3%, and sometimes it's down as much as 1,000% out. So we find that the radius distance, you have to imagine the sun travelling, you have to imagine it pregnant for, say, 4 days. Once the planet is born, it drifts out to a square root of the same distance, whereafter it takes a cubed period of time to complete one orbit. Now, one of the results of this is that you see that the planets, because the sun is travelling along, they actually travel along at a different angle to the sun. We find that Mercury here is travelling at about, I'll read that out, 22 degrees. Venus 29 degrees, the Earth 33 degrees, and then so forth. But by the time we get up to Uranus, the sun travelling like this, Uranus's spiral is very, very steep. There is more vertical than there is horizontal, like Mercury. Now, we also know that another strange phenomena is that the maximum angle of horizontal and vertical is the asteroids at 45 degrees, where the tension is so strong in the magnetic field that a planet cannot form, or if there was a planet there, it was disintegrated by the high tension that you get at that particular angle. Here's another view of the planets, giving the relative angle here. Yeah, not a very good one. but nevertheless, it does give you an idea of how it looks. Now, it occurred to me to exchange the usual two-dimensional image for an orbit for a three-dimensional version. This here, we see the sun coming up and the planet taking its spiral around. And we see a familiar image, do we not? This was the sun back in June. Just one last point on this connection between the gestation period of the planet and a significant time period, its orbit being the cube. Now, if we take a human being and we take the time from when an egg is released to it's fertilized to the fetus grows to birth, that is roughly 10 lunar months, which squared is 100 and cubed is 1,000 lunar months, which equals about 82 years, a significant period. I think you'll agree. So I'll leave it there.